Okay, so have you ever looked up at the night sky and wondered if there's anyone out there?
Oh, yeah, all the time.
Yeah. Well, that's exactly what we're diving into today with Alien Earths by Dr. Lisa Kaltenegger.
Oh, cool.
Yeah. So get ready because we're about to explore the mind of a scientist who's not just dreaming about distant planets. You know what I mean?
Yeah.
She's out there actually searching for life on them.
And she takes us along for the ride, which I loved.
Right.
What really struck me about this book was just how she blends hard science with those pinch me moments of discovery.
Yeah.
You know, it's like she's saying the universe is amazing and you can be amazed by it too.
Totally. And she
Yeah.
talks about growing up in a small town where the stars were basically part of the neighborhood
Really?
because the streetlights went out so early.
Wow.
And now she's leading a team at Cornell's Carl Sagan Institute.
That's amazing.
It's straight out of a movie.
It really is. It's a great example of how childhood curiosity can turn into a lifelong passion.
Yeah.
And, in her case, groundbreaking scientific work.
Totally. And speaking of groundbreaking, let's talk about Kepler 62e and F.
Oh, yeah.
These weren't just any exoplanets.
Definitely not. These are game changers.
Right.
These were some of the first planets that they found within the habitable zone of their star, but they were also close to Earth's size.
Wow.
So it really drove home that possibility that there could be other Earths out there.
It's not science fiction anymore. This is really happening.
Exactly.
So, okay, we've established that finding another Earth is mind-blowingly cool,
Totally.
but what makes a planet habitable in the first place?
Yeah. That's a great question.
I mean,
It's easy to think, okay, rocky planet, some water, we're good.
yeah.
But Dr. Kaltenegger paints a much more complex picture.
Yeah.
And she reminds us that Earth had a very rough start.
She does not sugarcoat it.
No, not at all.
Magma, oceans, toxic air,
Yeah,
not exactly a place you'd want to pitch a tent.
right. And no moon for most of it.
What?
Yeah.
Wow.
Could you imagine the night sky back then?
I can't even imagine.
Yeah, but seriously, this violent beginning is really crucial to understanding how Earth eventually became habitable.
Okay.
For instance, those early volcanoes were actually pumping out gases that help form our atmosphere.
So it's like a cosmic glow up.
Exactly. It starts out rough, but then over billions of years, things start to come together.
I love it.
And a key part of that is what Dr. Kaltenegger calls the Goldilocks zone.
Okay.
It's that sweet spot around a star where a planet is just the right temperature for liquid water to exist on the surface.
Okay, so not too hot, not too cold.
Precisely. But here's the thing, even with the perfect temperature, you need a way to regulate it over billions of years.
Okay.
And that's where the carbonate-silicate cycle comes in.
Okay, this is where I usually nod along, I get it.
Sure.
But can you break it down for me?
Yeah, so imagine it like a planetary thermostat.
Okay.
Volcanoes release carbon dioxide, which traps heat.
Right.
But then over millions of years, weathering and geological processes suck that CO2 out of the atmosphere and lock it away in rocks. Oh, wow.
So it's a really slow dance,
Right.
but this cycle prevents a runaway greenhouse effect.
Like a balancing act.
Exactly. And Venus is a perfect example of what happens when that balance goes haywire.
Oh.
Yeah, it's similar in size and mass to Earth,
Okay.
but it has a runaway greenhouse effect that's created a scorching inferno.
Oh, no.
Yeah, it makes you appreciate how delicate planetary habitability really is.
Yeah, Venus is like that friend who goes a little overboard at the buffet.
Right.
A cautionary tale, for sure.
Exactly. And that delicate balance is something she really drives home when she talks about the history of life on Earth, right?
Yeah.
I mean, we tend to picture our planet as this lush, vibrant paradise.
Right.
But for most of its existence, it would have been completely alien to us.
Yeah, she mentions this wild analogy in the book.
Oh, yeah.
If you condense Earth's entire history into a single 24-hour day, humans don't even show up until a few seconds before midnight.
I know, it's mind-boggling, isn't it?
It really is.
For billions of years, Earth was dominated by single-celled organisms.
It wasn't until the Great Oxidation Event about 2.4 billion years ago that oxygen even started to accumulate in the atmosphere.
Really?
Yeah.
So so much of what we consider normal is actually a pretty recent development when
Exactly.
you think about it that way.
And even more astounding is her work with extremophiles.
Okay.
These are organisms that thrive in conditions that would be deadly to most life as we know it.
Right.
She talks about tardigrades.
Tardigrades?
Yeah, they're these microscopic creatures that can survive being boiled, frozen, even blasted into the vacuum of space.
Wait, are you serious?
Yeah!
They can survive in space.
It sounds like science fiction, but it's true.
That's wild.
And it brings up a really interesting point. What if our definition of life is too limited? Like, we tend to look for life that resembles what we know here on Earth.
Right.
But what if life on other planets has found entirely different ways to thrive?
It's like she says in the book, imagining a banana as an alien life form.
Yeah.
It sounds kind of silly at first.
But it makes you question your assumptions.
Exactly. We might be limiting ourselves by looking for carbon copies of Earth when there could be whole ecosystems out there based on completely different principles.
It's true. So, okay, we've talked about what makes a planet habitable.
Right.
And all the wild possibilities of life beyond Earth.
Yeah.
But how do we even find these exoplanets in the first place?
Right.
I mean, they're incredibly faint and hard to spot.
It's like trying to find a firefly against a backdrop of 1,000 spotlights.
Oh, wow.
But over the last few decades, we've developed some pretty ingenious methods for detecting these distant worlds.
Okay.
One is called the Doppler wobble.
Okay, I've heard of that.
Yeah.
But to be honest, I'm a little fuzzy on how it actually works.
Sure. So imagine a star with a planet orbiting around it.
Okay.
The planet's gravity tugs on the star, causing it to wobble ever so slightly.
Okay.
And we can detect this wobble from Earth by observing the star's light.
So we're measuring the star's movement.
Yes, exactly. As the star moves towards us, its light waves are compressed, making the light slightly bluer.
Uh-huh.
And when it moves away, the waves are stretched, making the light redder.
Okay.
So this subtle shifting of the star's light is how we know there's a planet tugging on it.
Wow. That's some serious detective work.
It is.
I'm impressed.
And then there's another method called the transit method.
Okay.
And this is where we observe a star's brightness over time.
Yeah.
If a planet passes in front of the star from our perspective, it blocks a tiny fraction of the star's light,
Right.
causing a dip in its brightness.
So we can measure that.
Exactly.
Yeah.
It's amazing what we can do.
It really is. It's incredible how we can measure these tiny little changes in light from trillions of miles away.
It really speaks to the power of human ingenuity, right?
It does.
But Dr. Kaltenegger's work takes things a step further.
Okay, how so?
Her team is developing models to analyze the light passing through exoplanet atmospheres,
Wow.
searching for specific signatures that could indicate the presence of life.
So it's not just about finding these planets, it's about figuring out if anything's breathing on them.
Exactly. And you know what? These techniques have already led to some incredible discoveries.
Like what?
Well, for example, 51 Pegasi b.
Okay.
This was discovered back in 1995, and it totally upended our understanding of planetary systems.
Really? What was so special about that one?
It was a gas giant like Jupiter,
Okay.
but it was orbiting incredibly close to its star, something that astronomers at the time didn't think was possible.
Wow.
It challenged all of our assumptions about where planets could form and what types of planetary systems might exist.
So it's like finding a penguin in the desert.
Exactly.
Makes you wonder what other surprises are out there.
And speaking of surprises, the discovery of Kepler 62e and F, the planets are slightly larger than Earth,
Right.
but they orbit within the habitable zone of their star,
Okay.
making them prime candidates for harboring life.
It's like that moment in the movie where you think all hope is lost,
Yeah.
and then you realize there's still a chance.
And let's not forget about the possibilities of ocean worlds like Europa and Enceladus.
Oh, right. Those are moons, right?
Yeah, they're moons in our own solar system that are thought to have vast oceans of liquid water beneath their icy surfaces.
So there could be life swimming around down there right now.
It's a question that keeps scientists up at night.
I bet.
These ocean worlds really show us that the potential for life might exist in places we never even thought of before.
It's like we're living in a science fiction movie sometimes.
I know, right?
It's incredible to think that our own solar system, might hold the key to finding alien life.
Yeah, and that's just in our own little corner of the galaxy, right?
Right, exactly. What about, planets beyond our cosmic neighborhood?
Right. Well, that's where things get really interesting.
Okay, how
Because we're looking at light that's traveled across these vast distances of space.
Right.
We're actually seeing these planets as they were in the past.
Well, hold on. So you're saying when we look at these distant planets, we're actually looking back in time.
Exactly.
How does that even work?
So think about it this way. Light travels at a certain speed, right? A finite speed.
Right.
So the farther away something is, the longer it takes for its light to reach us.
Okay, that makes sense.
So when we observe a star that's, say, 100 light years away,
Yeah.
we're seeing light that left that star 100 years ago.
Whoa.
Yeah.
So if there were alien astronomers on a planet 100 light years away looking at Earth right now,
They would be seeing Earth as it was in the year 1924.
no way.
Yeah.
They wouldn't see our cities or our technology. They wouldn't even know that humans exist as we do today.
It's crazy, right?
That's both mind-blowing and kind of eerie, don't you think?
I know, it really puts things into perspective, doesn't it?
It does.
We often think of now as this universal constant,
Yeah.
but when you really think about it in the grand scheme of the cosmos, now is relative. It's this like constantly shifting tapestry of events unfolding across these unimaginable distances.
It makes you realize just how vast and ancient the universe really is.
Absolutely.
And speaking of ancient,
Yeah.
Dr. Kaltenegger mentions this other crazy concept, this thing called the cosmic microwave background radiation.
Yes. The faint afterglow of the Big Bang itself.
Like a baby picture of the universe.
Yeah, it really is. Like a snapshot of the universe just a few 100,000 years after its birth.
That's incredible.
Yeah.
It's hard to even imagine something like that, existing, let alone that we've actually detected it.
I know, it's amazing, isn't it? It really speaks to the power of science and human ingenuity.
It really does. And what I love about Dr. Kaltenegger's work is that it's not just about this like cold, hard data.
Right.
She brings a real sense of wonder and excitement to her research, and it's contagious.
It really is. It's inspiring.
It is. So for our listeners who are like taking this deep dive into alien Earths with us,
Yeah.
what would you say is like the biggest takeaway?
That's a great question. I think the biggest takeaway is that we live in an absolutely extraordinary time.
We do.
I mean, for like millennia, humans could only look up at the stars and wonder if we were alone out there, right? But now we have the tools and the knowledge to actively search for answers.
It's true.
We're discovering new worlds all the time.
It's so exciting.
Planets that could potentially harbor life as we know it,
Right.
or even life as we don't yet know it.
It's true. It's like we're on the verge of something really incredible.
I think so too.
Like anything is possible.
And that sense of wonder, that feeling that we're on the cusp of these great discoveries, that's what she captures so well in this book.
She really does. Well, this deep dive has been amazing.
It has.
It's been a wild ride through the cosmos for sure.
It has.
Full of mind-bending concepts and incredible discoveries.
All thanks to Dr. Kaltenegger.
Right. If you're even a little bit curious about the search for life beyond Earth, this book is an essential read.
It absolutely is. It will leave you wanting to learn even more about this vast and mysterious universe that we live in.
It will, and who knows, maybe someday soon we'll have like definitive proof that we're not alone.
Maybe.
Until then, though, keep looking up at those stars and never stop asking those big, important questions.
Never stop exploring.
Exactly. Okay, that's it for this deep dive.
That was fun.
I know. Till next time.
Exoplanets.